Hello everyone. Good evening. Good evening, everyone. Am I audible?
Yes, ma'am.
Yeah.
Yes,
Okay.
ma'am.
Okay then. So in the previous session we did the Bernoulli trial, binomial distribution, and hypergeometric distribution. So have we gone through the lectures once again? Like if you had any doubt or something, have you
No,
gone through
ma'am.
again? No?
No, ma'am.
Okay. Okay then. So that means you don't have any doubt in that topics, right?
Yes, ma'am.
Hmm. Okay. Okay. So you can see my screen, right?
Yes, it's visible.
Okay. Then. Okay. So today we are going to complete our last topic, which is the Poisson distribution. Okay. Shall I start with the session now?
Yeah.
Okay.
Ma'am, if you don't mind, before going ahead with this concept, can you just brief about, binomial heterogeometric, those who has
Okay.
not
So
gone through those. Just brief, not in depth, but maybe just brief, because those are
yeah, I
complicated
was
things.
thinking to brief the these distribution after completing the Poisson, like completely the binomial,
Oh,
hypergeometric, and Poisson all together. So if it's
perfect, ma'am.
quite all right with you, then I will do uh in that way. I was thinking to do that.
Yeah,
Is
that
it
that
fine?
works. Yeah, that perfect.
Okay.
Thank you.
Yeah, let me complete. This is the last topic. Then I will brief the whole the three distributions. Okay,
Yeah.
fine. Okay. Okay. So here we have with our last distribution, which is the Poisson distribution. Okay. So what is a Poisson distribution? It is basically the probability of number of events occurring in a fixed interval of time. So let's say like fixed interval of time or space, you can say. Okay, in a fixed interval. Okay, like number of accidents in a particular time or like a number of emergency cases that are arriving in a hospital and something like that. So the probability of the number of events occurring in a fixed interval of time is known as Poisson distribution. In that we use the Poisson distribution. Okay, so let's say my X is denoting the number of times an event occur in that particular time. Okay, then we say that my X is following a Poisson distribution with parameter lambda. So here lambda is known as the average. Okay, this is my average rate. So what is a Poisson distribution? Poisson distribution is that probability of number of events occurring in a fixed interval of time or space. And if I say my X is a random variable, which is denoting the number of times an event occur in that particular time or space, we say that X is following a Poisson distribution with an average rate of lambda. This is my average rate and this is known as a parameter also. This is the parameter of Poisson. Is this thing clear?
Yes, ma'am.
Yeah. Okay. And the PEMF is given by e raised to the power minus lambda, lambda raised to the power x upon factorial x. Are you familiar with this notation of factorial? See, the factorial can be written as this and this. Like both of the notations are same. Okay. So basically I'm used to this notation. So just be like, I wanted to tell you beforehand. Okay. So this is the PMF of a Poisson distribution, which is e raised to the power minus lambda, lambda raised to the power x upon factorial x, where my values of x are going from 0 to 1 to infinity. Okay. Is this thing clear?
Yes, ma'am.
Yes, ma'am.
Okay. Okay then. So let's see the shape of PMF of lambda. Okay. So the shape of Poisson distribution depends on the value of parameter lambda. And if lambda is small, the distribution has a positive skew. But as lambda increases, the distribution becomes progressively more symmetrical. So if my lambda value is small, it will be positive skew. But if I increase the value of lambda, it will be symmetrical. Okay. So let's see that. Okay. So here, if you see my, okay, now it's clear, right? You can see the screen, right? It's clear?
Yes, ma'am.
Okay. So, so here my lambda value is 1. So if you see in the graph, it is positively skewed, right? But if we increase the value of lambda, so here my lambda is 4. So it is progressively more symmetrical, right? It is going to be symmetrical. Similarly, if I increase lambda more, my lambda is 8 now. So it is symmetrical. Understood? So if my lambda value is 1, it was positively skewed. But as I increase the value of lambda, it is getting to be symmetrical. Understood? Is the graph clear?
Yes, ma'am.
Okay. So now
Yes,
let's
ma'am.
do, okay. So now let's do the expectation of a Poisson distribution. Okay. So, okay. So basically my expectation, what is the formula of expectation? It is basically summation of xi into px, right? So here it would be equal to summation of x e raised to, what is the probability of Poisson distribution? It is basically e raised to the power minus lambda, lambda raised to the power x upon factorial x, correct?
Yes,
And here
ma'am.
my x is equal going from 0 to infinity. Okay. Now I can write this as summation of x e raised to the power minus lambda, lambda raised to the power x plus 1 minus 1 upon this factorial x can be written as x into x minus 1 factorial. Can I write this in this way?
Yes, ma'am.
Okay. Now this would be summation of x e raised to the power minus lambda, lambda into lambda raised to the power x minus 1 upon x into x minus 1 factorial. Is this step clear? Is this step clear to everyone? I just like this can be written as lambda raised to the power 1 into lambda raised to the power x minus 1.
Clear, ma'am.
Okay. Now this x will get cancelled. So now this is a constant term. So I will just take it out. So e raised to the power minus lambda into lambda summation of lambda raised to the power x minus 1 upon x minus 1 factorial. Okay. Now, and this is basically my expansion of e raised to the power lambda. So I can write this as e raised to the power minus lambda, lambda into e raised to the power lambda. This is this summation. This lambda raised to basically my summation of lambda raised to the power x upon factorial x is equal to e raised to the power lambda. Okay. So if I have here, if you see in place of x, I am having summation of lambda raised to the power x minus 1 upon factorial x minus 1. So I can write this as e raised to the power lambda. Correct?
Yes, ma'am.
Okay. So now e raised to the power minus lambda get cancelled with e raised to the power lambda. So I'm left with lambda. So here we see that my expectation of x is equal to lambda. Okay,
Okay, ma'am. Got it.
it's fine. Yeah. Okay, the summation. Okay, I didn't write the values. So it will be x raised to if x is equals to 1 to infinity. So here also x is equals to 1 to infinity. Okay. So x 1 to infinity, when x is going from 1 to infinity and lambda is sorry, this would be 0 to infinity and this is 1. Okay. So when x is equal to 0 to infinity, lambda raised to the power x upon factorial x is equals to e raised to the power lambda. And when x is going from 1 to infinity, lambda raised to the power x minus 1 upon factorial x minus 1 would be equal to e raised to the power. Okay. So my expectation is coming out to be lambda. Similarly, I can calculate the value of variance. Okay. What is the formula of variance? It is equal to e raised to the expectation of x square minus expectation of x whole square. Okay. This is my formula of variance. Okay. Now we got the value of ex, right? We need to find out the value of ex square. So if I have to find out the value of ex square, I can write this as expectation of okay. Okay, I can okay. Expectation of x square can be written as expectation of x minus 1 plus expectation of x. Can I write this in this way? Expectation of x square. If you just open the brackets here, you will get expectation of x square minus x plus expectation of x. Okay. Then this would be equal to expectation of x square minus expectation of x plus expectation of x. This would can cancel. We will get expectation of x square. So can I write expectation of x square like this in this way? I can, right?
Yes, ma'am.
Okay. So first of all, we will find out this value. Okay. Which is expectation of x into x minus 1. Okay. In the similar way, which will be summation of x into x minus 1 e raised to the power minus lambda, lambda raised to the power x upon factorial x. Okay. Now, similarly, in that way, I will be taking out common, which will be x into x minus 1 e raised to the power minus lambda, lambda raised to the power 2 into lambda raised to the power x minus 2 upon x into x minus 1 into x minus 2 factorial. Is this step clear? It's the same step that in the before I did x minus 1, right? So here I'm doing x minus 2 plus minus 2. Is this fine? Is this step clear?
Yes, ma'am.
Okay. Now here this will get cancelled. So I will be left out e raised to the power minus lambda, lambda raised to the power square. Summation of lambda raised to the power x minus 2 upon x minus 2 factorial. Here my x is going from 2 to infinity. Now this value is equal to what?
C to the minus x minus 2, right?
E raised to the power what?
X minus 2.
No. My summation lambda raised to the power x upon factorial x
Oh,
is
okay, okay,
equals to
okay. Yes, yes,
lambda.
because x
Not
goes from 2 to infinity, right? So
Yeah.
minus, I
So
have to
this would be
subtract the
equal to
2
what?
first terms.
Hmm? This would be equal to e raised to the power lambda.
Yes, ma'am.
Okay. Now this would can cancel. We will get lambda square. So we get that expectation of x minus 1 is equal to lambda square. Now we have to find out the value of expectation of x square, which is lambda square plus lambda. If we go through this formula plus expectation of x, correct? This is my expectation of x square. So now variance of x would be equal to lambda square plus lambda minus lambda whole square. This is my expectation of x square and this is my expectation of x whole square. Is this clear? Are you getting it?
Yes, ma'am. This is clear.
Okay. So now lambda square will get cancelled. Lambda square will get cancelled, so I will be left out with lambda. So here we see that my variance of x is equal to lambda. So we see that my expectation and that is my mean and variance is equal to lambda only. Okay. So for a Poisson distribution, both the expected value and the variance, okay, they are both equal to lambda. Okay. Just remember that. Understood?
Yes,
Is
ma'am.
this
Yes, ma'am.
Poisson distribution is clear? Okay, let's do one example. Okay, so suppose the okay, let's do one example, just a second. Okay, you can see my screen, right?
Yes, ma'am.
Okay. Can you see this question? This one. You're able to see it?
Yes,
Yes, ma'am.
ma'am.
Yes, ma'am.
Okay. So I need to do like you have pen and paper, right?
Yes, ma'am.
Okay. So just have your pen and paper and solve this question. So here we have been given that suppose the number of accidents per week in a factory can be modeled by the Poisson distribution with a mean of 0.5. So what is this value actually?
Lambda.
Lambda.
This is lambda. So basically this is my lambda. Find the probability that in a particular week there will be less than 2 accidents. So we need to find out like if x is my probability, x is a random variable denoting the number of accidents per week. So I have to find out probability that x is
0 and x equal to 1. So,
0, 1, and right?
so P of x equal to 0
no,
plus
I need like what I need to find probability of x what?
x equal to 0
Hmm.
and P of x equal to 1. So which is nothing but accidents in a particular week less than 2 accidents.
Less than 2 like can be not be others, it will be less than 2 accidents. Yeah. So it will be probability of x equals to 0 plus probability of x equals to 1. So now, okay. So what is the PMF of a Poisson distribution?
E power minus lambda into lambda power x prime x factorial.
Factorial.
So for x equal to 0, e power minus 0.5 lambda power 0, which is 1 divided by 0 factorial.
Okay. So tell me the answer.
Yeah.
Everyone is solving it?
So it's 3 by 2 times e to the minus half.
What?
Zero point 909.
909. Yeah. Everybody is getting that answer, right? Are you guys solving?
Yes, yes, solving.
Okay, okay.
Just give us 2 minutes.
Yeah, sure.
Good evening, ma'am.
Good evening.
I'm sorry to interrupt in between. I want to ask what is the week by syllabus of Fenton?
It is basically from 9 to 12.
Yeah, it is from 9 to 12, but what about the weightages of the week from week 1 to week 8?
It won't be that much, like 10% or something. Not that much. But basically, 90% of the paper would be from 9 to 12.
So the rest of the weeks are not that important.
You have to score good marks, then that's an important.
No,
Sorry.
I'm asking about that. Is it not that much important?
No, if you go with the weightage and all, then you only tell me, is it important or not? It's up to you.
Ma'am, I got 0.909.
So everybody is getting that answer, 0.909 something.
Yes, ma'am.
Okay. So let's see here. So this is X number of accident probability. Yes. One. Maybe there is some
Some mistake in answer.
okay, there must be some mistake in this question. Only one, 0 and 1 should be added. One, two,
Less than 2.
Yeah, they said less than 2, but not less than or equal to 2. Right?
yeah,
So
correct.
third
There must
one
be
we
some
need to,
mistake.
we should
Yeah.
not do.
Less than equal to 2x. Then.
Okay, it's fine. Let's do the other
Ah.
question. Okay. Mhm. Okay. Now, the number of dogs that are killed on a particular stretch of road in Chennai in any one day can be modeled by a Poisson 0.42 random variable. So this is basically our lambda. Now calculate the probability that exactly 2 dogs are killed on a given day on this stretch of road. Okay. So you understood the question?
P of x equal to 2. We need to find
What we need to find probability of
x equal to 2.
X equal to
2.
2.
Yeah. So what's the answer you're getting?
Let me calculate.
Hmm.
I'm getting
0.0.
0.4647.
What? 0 point?
4647 I got.
And 0.0580.
Yeah, correct. This is the answer. Just check it once again.
I got 0.0585.
0.0585.
Yes, ma'am.
Maybe there is some decimal error or something. It's fine. But the one who was getting 0.4 something, you got the mistake.
Checking.
Okay, other than like others, you're getting the answer?
Yes, ma'am.
Okay.
Yeah, even I got the same.
You got the answer, right?
Yes, yes.
Okay, now. Okay, so next question. Find the probability that exactly two dogs are killed over a 5-day period on the stretch of road.
It should be okay. It is given that on one day two dogs been killed. So for 5 day it should be that into
So
five.
here,
So
And
see,
lambda equal to 5 into
5 into
0.42.
0. Yeah,
correct, 5 into 0.42, which will be equal to
2.1 or something. Yeah, 2.1.
2.1, right? So now here my x is following a Poisson distribution with lambda is equals to 2.1. Okay. Now I have to find out the probability that x is equals to 2, right?
Yes, ma'am.
Yes.
Yeah.
Yeah.
So tell me the answer.
Zero point two seven zero.
Correct. Everybody is getting that answer?
But 0.26.
What about others? Like the answer is 0.27. Just check
Yeah,
it once again.
0.2699.
269. So just round it off to 27. Yeah.
0.269. Yeah.
269. So it would be 0.27. Like if you round it off. Okay. So this is
Approximate.
the, yeah. So this will be probability of x equals to would be equal to 0.27. Fine. Is this question clear to everyone?
Yes, ma'am.
Fine. Okay. Let's do one last question. Okay. This modeling type, this question. A typist makes 1500 mistakes in a book of 500 pages. Let x be a number of mistakes per page. Then x is following a Poisson distribution with 3 as the parameter. On how many pages would you expect to find no mistake? Okay, this is the first question. Like you have to find out the probability that how many pages would you expect to find no mistake. That means you have to find out probability that x is equal to
0, right?
0.
x is equals to 0. Correct. Yeah. Solve it and tell me the answer.
Lambda is 3.
Okay, so the thing is like Okay, just read the question carefully. We have to find out on how many pages would you expect to find no mistake. Okay,
Lambda
just
equal to 3.
yeah, lambda is 3. This is our lambda, right? So just read the question carefully. What you need to find out. You need to find out how many pages would you expect to find no mistake. Okay.
No, it's 1 minus the probability that he makes mistakes, right?
1 minus, sorry.
So it's 1 minus the probability that he makes mistakes. X equal to the number of mistakes, right?
So how many mistakes did he make? It's 1500. So you're going to calculate the whole. What's your approach?
0.050.
Yeah, 0.0497.
That's the probability, but I like the question is asking about how many pages. So how will you calculate? So in this, it is saying that it is making 1500 mistakes in a book of 500 pages. Okay, so in total, I am having how many pages? 500 pages. So here it is asking how many pages would you expect to find no mistake, right? So my x is what is my x? X is the number of mistakes per page. So if I'm having 500 pages, so 0.049 into 500 would be my answer. See, in this question, it is saying for one page, the probability of getting no mistake is 0.049. So what about the 500 pages? It would be 0.049 into 500, correct?
Somewhere near to 250 pages.
So this would be equal to 25 something. Got it? So that means in 25 pages, I'm having no mistakes. Everybody got the solution?
Yes, ma'am.
Okay.
Yes,
So here
ma'am.
we have calculated the probability of x equals to 0. Then the number of pages with no mistake would be this probability into 500, which is approx 25 pages. Okay.
Yeah.
Now the how many pages would you expect to find one mistake? This would be equal to probability of x equals to 1, which is 0.149, then multiplying it by 500. Yeah. So which will approx will be equal to 75 pages. Then the third question, 3 or more mistakes. Calculate the third question. Let's solve this question. 3 or more mistake and tell me the answer.
For the third one, we'll take P0, P1, and P2, and then take 1 minus and the complement of this, right?
Yes, correct.
289.
Yeah, approx 288 pages. What about others? No, I got the answer. You guys solving? We need more time.
Yeah, even I got the same number around 280 pages.
Okay. Okay. Are you guys done?
Yes, ma'am.
Yeah, just tell me if you are done. I was waiting. So what's the answer that you are getting? Sorry?
340 and 5.
Sorry?
It's 285.
288, right? Everybody is getting that answer?
Yes, ma'am.
Yeah. So it is basically 1 minus probability that x is equals to 0 plus probability of x equals to 1 plus probability of x equals to 2. Getting this probability multiplied by 500, we are getting approximately 288 as the pages. So is this question clear?
Yes, ma'am.
Okay then. So I think this topic is clear. Poisson distribution clear to everyone?
Yes, ma'am.
Okay then. So shall we have a brush up of all the distributions?
Yes, ma'am.
Okay then. So the first one was the Bernoulli trial. Anyone having any idea? What is the Bernoulli trial?
So there are only two chances. One is for success and another is a failure.
Correct.
So for two probable outcomes. So P
Okay.
and 1 minus. So 1 and 0.
Yeah.
So 1
So
occurs
with probability
P.
P and 1 minus P. Correct. So this is my Bernoulli trial. Okay. With expectation is
Finish,
equals to
Yes.
what is the expectation?
N
Okay.
into N into
NP.
yeah, NP.
Are you sure?
It's P only.
It's P only because this is a Bernoulli trial. Okay. And variance of x would be equal to
P times 1 minus P.
1 minus P. So this is my Bernoulli trial. So in Bernoulli trial, we have two outcomes, which is success and failure with probability P and 1 minus P, with expectation P and variance P into 1 minus P. So this is my Bernoulli trial. The main thing is that you should have two outcomes, which is the success and the failure. Understood?
Yes, ma'am.
Okay. Then we have the binomial distribution. Anyone?
So expectation of binomial distribution is P.
No, I want to know what is a binomial distribution. How can you identify whether that experiment is a binomial distribution or not? So the main thing is you should have n independent trials. Correct? Nobody remembers?
Yes, ma'am.
Yes, ma'am.
Okay. So we should have n independent trials. And if my x is following a binomial distribution, sorry, my x is what? The number of success. In
Having
n
the
trials,
equal.
then my x is following a binomial distribution with parameter n comma p, where n is my number of independent trials and p is the probability of success. And can you tell me the PMF of binomial distribution? It would be
X,
n
NCX,
NCX p raised to the power x 1
1
minus p raised to the power n minus x. Okay. And what is the expectation?
It's NP.
It's
Yeah.
np, and variance of x is equal to
N
NP
times
1 minus P.
correct. So is this thing clear? Binomial distribution. We should have n independent trials. X should be the number of success in n trials. Then x is following a binomial n comma p. These are the parameters. We have two parameters. And this is the PMF and this is the expectation and variance. Okay. So the main important thing that you should have n trials, n independent trials. Okay. If there is no independent trials and only success is given, then it is not a binomial distribution. Okay. These two distributions are clear, Bernoulli and a binomial.
Yes, ma'am.
Okay. Then we have a third distribution, which is hypergeometric. Anyone wants to speak up?
So if it is not independent,
Yeah. So the main
And
important thing that it should be without replacement.
Changing probability.
Sorry. Somebody was speaking something.
maybe background noise.
Okay, it's fine. Okay, so in hypergeometric distribution, the main important thing that the sampling should be without replacement and the probability should be changing in each instant. Okay, like these are the most important thing. And so what is my hypergeometric distribution states? So if I randomly select n items from n population, okay, with m of the items of one type, okay, and n minus m of other type, okay, then the probability mass function x equals to x is given by mcx n minus, anybody remembers?
Yeah, yeah. N
N
minus
minus M. N
Uh,
minus
C, N
X.
minus M.
divided by
N by
NCM.
NCM.
NCN. Okay, so this is the PMF. Okay, so if I'm choosing n items from n population where m is of one type and n minus m of other type, then the probability that the PMF is given by NCX n minus m n minus x upon NCM. Okay, and what is the formula of expectation?
NM
NM
by
by
capital N.
capital N.
Correct. And what is the variance?
It's N into M divided by N into N minus M by N into N minus N by N minus 1.
Correct. This is my population correction. Okay.
Ma'am, can
So-
you explain the last you circle, right, like the term? So what is the main importance of that term? Know if
Okay,
n is very
so
small or if n equal to 1.
So basically, okay, if you remember, like for the binomial case, it was NP1 minus P, right? For the binomial case, the variance was this. Okay, so basically, in particular, if you see, my P is equal to M by N. According to hypergeometric, my probability of success is basically M by N,
Yeah.
right? So this is basically what? NP1 minus P, correct? It is
Yes.
same as
Yes.
binomial. But in hypergeometry, there's one extra term which is n minus n upon n minus n, which is my population correction. That means like if the value, so okay, my n minus n, I can write this as n minus n upon n minus 1. I can write this as 1 minus n upon 1 minus 1 by n. Correct? I can write this in this
Yes.
way. Correct? Now, if this fraction gets increased, like if I, okay, let me explain you through the, okay, if you see here, okay, you are making a graph between a binomial and a hypergeometric. So this is the case, this blue one is the case of binomial and this is the case of hypergeometric. So here we are taking n is equals to 5, the probability is 0.5, okay? And in this case, we are taking capital N as 500. This is my sample 250. This is my n items, with, like choosing 5 items. And this is my, like the proportion n upon n, which is 1%, okay? So this 1% means that is 0.01. That means my 1 minus n upon 1 minus 1 by n. So this proportion is basically what? 0.01. That means there is no change. So basically my hypergeometric and my binomial distribution would be same.
Yeah.
Correct? Now, if we increase the value, so here I've increased to 5%, okay, then there will be minute changes. So if you see in this graph, the like the variability, if you see, a little bit has changed, right? The probability has decreased, correct? Like the blue one is little lower than the red one, if you see here,
Yes.
right? Okay, now I've increased to 10%. Now you see the graph, that it changes, right? So if we see here, the blue one is like the way the probability of binomial distribution is getting lower. There is like an increase of variability compared to the hypergeometric. If I increase more, if you see here 50%, right? That means 0.5% changes there. 0.5%. Sorry, 0.5 changes there. So here I'm getting the variability in binomial but less variability in the hypergeometric proportion. Sorry, distribution, right? So if I multiply this n by n, this parameter, na, 1 upon n divided by 1 by n, this is getting multiplied my variance of y. So basically my y is following a binomial with parameter n comma p. Okay, and my variance of y is basically np 1 minus p, right? So if my x, I'm considering x as a random variable which is following a hypergeometric with parameters n comma m comma n. Okay, for this my variance of x would be equal to n m by n, what was that, n minus m by n, and I'm considering this as the like this is my correction factor, correct? So this is basically my what, variance of y equal to approx variance of y. My variance of y is getting multiplied by this correction factor. So if my n upon is 55, that is 0.5%, right? So if I multiply this factor with the variance, it will get more smaller than the variance of binomial distribution. So that's why we see here in the binomial distribution, I'm getting more variability than the hypergeometric distribution. Okay, so if my this parameter gets increased, my variability will get decreased in the hypergeometric distribution. Understood?
Yeah.
Yeah, that's the point of this population correction. Okay, so that's the expectation and this is the variance. Understood? Hypergeometric is clear?
Ma'am, am I audible?
Yes.
Ma'am, I have a doubt in distinguishing between binomial distribution and hypergeometric. You mentioned that the keywords with and without replacement, right?
Correct, correct.
But how do we distinguish that in questions?
If it's without replacement, like it would be like in the question only, it would be stated that if we are sampling without replacement or with replacement. So basically, the
Stated,
thing
right?
is like if we are having a bag, okay, if you remember this example, where is it?
Yeah, examples like taking balls from a
Yeah.
box.
So here we have balls, correct? Okay. So if here, okay, so I am having a bag full of balls. So this is my population. So in total, I'm having 6 balls. Okay, so this is my population. This is my n. Okay, in that n, I'm having 2 distinct like the samples, which is 4 white balls and 2 black balls. Okay, these are my 2 distinct subparts, right? So the first part, it was stating that my population should be divided into 2 independent subparts, which is like 4 white balls and 2 black balls. Okay, now the thing is we are sampling without the replacement, right? So we are not replacing it. If we are taking off one ball, that ball is like we are not replacing it with the other ball. Okay, so now in the first case, I'm taking out one white ball. Okay, so I have chosen one white ball. So in the remaining in that bag, I would be having 3 white balls and 2 balls. It's without replacement, right?
Yes, ma'am.
Right? So this is the case. Like in without replacement. So like, do you know the difference between with replacement and without replacement?
Yeah, if we take it with replacement, we take it and keep it back, right?
Keep it back, correct. So if it's with replacement, then it's a binomial distribution. If it's without replacement, then we see that it's a hypergeometric distribution.
So the
And there's
keywords with and without replacement will be mentioned in the question, right?
it would be mentioned in the question. And the most important thing, that the population should have two subparts like this: four white balls and two black balls.
Okay.
Okay,
Yes, thank you.
that's the main difference.
Yeah.
Okay,
Thank you.
okay. So this hypergeometric is clear.
Yes, ma'am.
Okay. Then we have the last Poisson distribution. Anyone?
Yeah, which we discussed in
Fixed
the starting.
interval
So,
of time.
Correct. What fixed interval
so
of time?
uh,
What
uh,
do you have to
at the
calculate?
rate of average rate.
So what is my x stating? Just a second. Just hold first. Okay. So okay. So Poisson distribution. What is my x? So x is basically the number of events happening in that fixed interval of time. Correct?
Yes, ma'am.
Yes.
Okay. So x is my number of events are happening in that fixed interval of time. So my probability of x, the PMF is given by e raised to the power
Minus lambda
Minus
into
lambda into
lambda
lambda
power
x
x
by
by
Okay.
x
x
power
So where
factor.
my lambda is what?
It's
Average rate.
yeah, average rate of an event.
Average rate. Correct. And what is my expectation?
Lambda.
Lambda.
Lambda. And variance?
Lambda.
Yeah.
Lambda. Correct. So in the Poisson distribution, my expectation and variance is equals to lambda. Okay. So I hope everybody understood the whole three distributions: the binomial, hypergeometric, and Poisson.
Madam, in Poisson distribution, there is no point of dependency or not dependency question.
No,
Hmm.
nothing.
Okay. It's just we are considering if anything is happening at the average rate and
At
within
that
this
fixed interval of time. Yeah.
fixed interval, then
Yeah.
we need to use this. Okay. Yeah,
Correct.
got it.
Okay. So this week is clear. This week 11 lectures are clear to everyone.
Yes, ma'am.
Yes,
Sure.
ma'am.
No doubts. Have you solved the activity questions or the graded assignments?
Yes, ma'am.
Okay. Okay then. So nobody's having any other doubts. So shall we end the meet or?
I'm clear. And, thanks for taking us through this.
Sorry.
Yeah, I'm clear from my side. And
Okay.
thank you very much, for taking
Okay.
us through
Thank you,
this.
everyone. Okay. Thank you. Yeah.
Bye.
Bye.
Thank you.
Okay then. So I guess nobody's having any doubts. So shall we end the meet now? Then
1 second. What about
okay.
normal distribution?
Normal distribution would be in next week. That is week
Next
12.
week. Okay.
Yeah.
Thank you.
So that's in continuous. Basically, our Poisson, our hypergeometric, binomial, and Bernoulli, they are from discrete random variable.
Okay,
the
so you'll
next,
do that in the
yeah,
next step.
yeah. So
Okay.
the continuous would be studied in the next week. That is week 12.
Okay, ma'am. Thank you.
Okay. Okay then.
Thank you, ma'am.
Thank you, everyone. Have a great night.
Thank you, ma'am.
Thank you.